Question 14 of the Madas MP1 Paper N series. So the figure above shows a trapezium OBCA where OB is parallel to AC. Right, let's get that down. So that's parallel to this. The point D lies on BA so that BD to DA is 1 to 2. Right, so for every one of that, there's two of those. That means BD equals 1/3 of BA. Right, because it's a third of the way along. It's further given that O to A is 7i minus 4j, O to B is 3i plus 2j, AC is 2 lots of OB, where I and j are mutually perpendicular unit vectors lying on the same plane. To determine simplified expressions in terms of I and j for each of the following vectors OC, AB, AD, and OD. Right, O to C. So let's do that first. O to C. Well, how am I going to get from the origin O to C? Well, I could go O to A plus A to C. Is that a thing? Yeah, I could go O to B, BC. That's fine, but I'm probably going to do that. So let's think about it. So O to C is O to A, which I know is 7i minus 4j, plus A to C, which is 2 lots of O to B, so that's 2 lots of 3i, so that's 6i, plus 2 lots of 2j, which is 4j. And lo and behold, OC is going to be 7i plus 6i, which is 13i, and minus 4j plus 4j will cancel, so I'll get O to C is just 13 lots of I. Not bad, so that's that one done. A to B. Okay, so A to B, I'm probably just going to do A to O plus O to B, and A to O is the same as the negation of O to A. If I reverse the direction, I have to change the sign. So A to B is going to be the negative of O to A, and O to A was 7i minus 4j, so that's minus 7i plus 4j. And O to B is 3i plus 2j, so plus 3i plus 2j. So add all this stuff together. Minus 7i plus 3i is going to be minus 4i, and 4j plus 2j is going to be 6j. So that's A to B. So that one's done. A to D. Okay, so A to D, if we think about it, if B to D is 1/3 of B to A, then we have to go 2/3 of A to B along. So A to D is 2/3 of A to B. Does that make sense? Yes. Have we done A to B already? Yes, it's over here. So I need to do 2/3 of this thing. So 2/3 of minus 4 is going to be minus 8/3 of I, and 2/3 of 6 just becomes 4 lots of J. So that wasn't too bad at all. So that's A to D. O to D. O to D. Right. Okay, what do we know? Well, we can do O to D, we can do as O to A, which we know, plus A to D, which we just worked out in the previous bit. So O to D is going to be O to A, which we know is 7i minus 4j, plus A to D, which is minus 8/3 of I plus 4j from the previous part. 7i minus 8/3. 7 is 21/3, so 21 minus 8, I believe, is 13/3 of I, and minus 4j plus 4j is nothing, so O to D is just 13/3 of I. That's particularly interesting because that means it's parallel with O to C. And it says, deduce your reasoning that ODC are collinear. Well, yes, they are, because O to C if that's for every 3 parts, O to D is 1/3 of it to 1. So yes, they are collinear because they both lie as just multiples of the unit vector I. So they're clearly collinear, they lie on the same line. Show that OBA, that angle, is 90 degrees, hence find the area of the trapezium OBCA. Right. Okay. Well, let's do this then. OBA. Well, how do we get from O to B? That's 3i plus 2j. So the gradient of OB is the change in y, which is 2, over the change in x, which is 3. Okay, and the gradient of B to A, now let's think about this very carefully, is the negative gradient of A to B. Because, well, A to B, the gradient of A to B is the change in y, which is 6, over the change in x, which is -4. But then if I do B to A, that's going to reflect that. So that's going to be a minus. Oh no, it's not. Interesting. It's the same gradient. So that's -3/2. Aha! One has a gradient of 2/3, one has a gradient of -3/2. They're negative reciprocals. So that means OBA is 90 degrees. Yes. Hence find the area of the trapezium OBCA. Right. So to find the area of this trapezium, we're going to need to do the length of the 2 parallel sides added together and halved, and then times by the perpendicular height. Okay, that's not too bad. O to B, well, O to B is 3i plus 2j, so doing Pythagoras, 3 squared plus 2 squared is root 13. So that's root 13. A to C, have we done A to C yet? No, but we know it's 2 lots of O to B, so this is 2 root 13. Okay, we add those together, divided by 2, we're going to get 3 root 13 over 2. And now we have to times that by the length from B to A. Well, we've got A to B over here, so we're going to have 4 squared plus 6 squared square rooted, which is root 52, which I believe is 2 root 13. 4 times 13 is 52. Pack of cards. Yep, so this becomes 2 root 13. The 2 and that 2 cancel. 3 times root 13 is 3 times 13. So that appears to be 13 units squared. Okay, and then part D, state the size of the angle ABC. Okay, state. So what can we... Oh, okay, so because these two sides are parallel, we've got like a cheeky... This is going to get confusing, but we've got like a Z angle here. We've got alternate angles, so this angle must be 90. What is the length of A to B? That would be nice to know, because we could maybe do some SOHCAHTOA stuff. A to B is 4, 6i. Oh wow, that's going to be the same numbers, isn't it? So that's also 2 root 13. Ah, so this is an isosceles, right-angled isosceles, so this is 45 degrees. So yeah, quite simply, that's just 45 degrees. Yeah, because if you've got a right-angled isosceles, where the two sides are the same like that, then these must share the 90 degrees that's left over equally, so it must be 45. Yeah, very sneaky.